Good afternoon, everyone. Welcome back. I hope that everybody had a great weekend and that you're all doing okay. We're going to move on today and look at lesson 31.03, which deals with what we call function symmetry, and this can be found on page 14 of your lesson handout. For the next couple of weeks, we are going to be really focusing on developing methods that we can use to graph functions, and we're going to be graphing these functions without the use of a calculator or any kind of technology. And there's a lot of layers to graphing these functions. There are, depending on the function, sometimes between 6 and 10 different things that you have to figure out, and then when you put all of these pieces together, you're able to figure out what the function looks like. And the first thing that we're going to be talking about is what's called function symmetry. And in your handout on page 14, there is a serious mistake with the graphs. When I pasted these graphs in here, I pasted them in the wrong places. So at the top where it talks about a function having even symmetry, and I'll get to what that means with the function notation in a second, even symmetry is actually the graph at the bottom of the page. So even symmetry looks like a butterfly would look like. The left and the right sides are just mirror images of each other. I know that doesn't look like a butterfly, but if you drew a butterfly, the left and the right-hand sides would look identical, except they would be reflections of each other. And when I talk about odd symmetry, a function is defined to have odd symmetry, and then there's a description of it, which we will get to. That refers to the graph at the top of this page. So one of the ways you can fix this in your note handout is to actually do what I've done here, to make some marks and arrows pointing from the statement to the proper graph. Or if you want, I've already gone into the PDF and edited it. So if you were to download that PDF file again and print out just page 14, then it would look correct. Either way, you need to understand that an even function has that nice symmetry to it where the left and the right side are equal to each other. The odd function has this other kind of symmetry, which we're going to talk about in more detail in just a minute or two. So let's talk now about even symmetry. A function is defined to have even symmetry if the graph of the function is symmetrical with respect to the y-axis. I'm going to get to the function notation in a second, but what symmetrical with respect to the y-axis means is that if you were to take and reflect the left side across the y-axis, and that's the same kind of reflection that we talk about in Math 30-1. If you were to reflect the left side across the y-axis, which is a horizontal reflection, then you would end up getting the other part of the graph. So if I take this and I'm just going to clone it, and I'm going to reflect it horizontally, which is left-right. Of course, it doesn't just reflect and land where I've got it. There is an invariant point, which is on the line of reflection. The invariant point, of course, is the y-intercept. So this point is fixed. So that's how you can visually see if a function has even symmetry. Now, what's the deal with this highlighted thing at the top, which says f of negative x equals f of x? Okay, well, I'm going to come up with the coordinates of a point. I'm going to label a point on this graph. And let's label this point right here. I'm going to say that the coordinates of that point are 12, 3. And if I asked you to determine the coordinates of this point, I don't think it's a really difficult task. Because of the symmetry here, you know that the x coordinate is going to be negative 12, but the y coordinate is still 3. They both have the same y coordinate. The distance from that point away from the x-axis and the distance from this point away from the x-axis are both 3. Okay, so let's compare those ordered pairs to the statement f of negative x equals f of x. I know that f of 12 is equal to 3, and I know over here that f of negative 12 is also equal to 3. All this statement is saying is when you change the value of x by multiplying it by -1, you get the same y coordinate. I could pick some other points here to drive the point home. If I were to pick this point and tell you that the coordinates of that point are -8, -2, and I said to you, well, what are the coordinates of this point? I hope you would say the coordinates of that point would be +8, -2. So again, when you go from an x coordinate, in this case of -8, to the negative of that x coordinate, which would make it +8, the y coordinate stays the same. That's what f of negative x equals f of x means. Now, when we do our work a little bit later in the examples that we're going to do today, we don't use numbers. We do it in an algebraic fashion. Now, what about an odd function? An odd function, well, let's take a look at what it looks like first. An odd function looks like that. That's an example of an odd function. And I want you to notice that if I were to go from, say, this point to its what I'm going to call sister point, I hope you can see that those 2 points are symmetrical with regards to each other. Or if I were to go from, and I'm picking on max mins because they're easier for me to locate, from that blue point to this blue point, the next one I will choose one that's not a max min. Or if I were to go from this point to this point, I can arrive at the new point from the old point in all 3 of these cases by doing 2 things. I can reflect things vertically and then reflect them horizontally. So if I were to take this red point that's on the left and I were to reflect it vertically, it would end up down here. If I were to then reflect it horizontally, it's going to end up way over here. If I were to reflect the blue point on the left vertically, then it's going to end up above the x-axis. When I reflect it horizontally, it will end up over at the other blue point. So in order to go from one point to its sister point, what you have to do is reflect horizontally and vertically. And you could certainly figure out the meaning of this function notation at the top by doing that and applying the rules we learned in Math 30-1, which is that x gets multiplied by -1 and y gets multiplied by -1. But I don't want to get into that. I just want you to understand we're talking about 2 reflections here. So if I told you now the coordinates of a few points, let's take this green point at the top, and I told you the coordinates of this green point at the top were 1, 10. And I told you the coordinates of this red point over here on the left was -17, 3. And I told you that this blue point over on the right was 15, 3, and asked you to fill in the coordinates of the blue point on the left and the coordinates of the green point on the bottom and the coordinates of the red point on the bottom. You could do it by using the reflections I've talked about. If we start off with the green point at the top, if I reflect it horizontally, the x coordinate becomes -1. If I reflect it vertically, the x coordinate becomes -10. If I take the red point on the left-hand side and I reflect it horizontally, that negative 17 becomes positive 17, and the 3 becomes negative 3. If I take the blue point on the top and I reflect it horizontally, the x-coordinate becomes negative 15, and when I reflect it vertically, the y-coordinate becomes negative 3. So what's happening is, as the x-coordinate switches signs, goes from, say, negative 15 to positive 15, the y-coordinate switches signs as well. It goes from negative 3 to 3. Or when x goes from negative 17 to positive 17, y goes from 3 to negative 3. That's what this statement at the top is saying. It's saying that when you switch x, you get an opposite y. Now, if f of negative x is not equal to f of x, which means it's not even, and f of negative x is not the same as negative f of x, then it's not odd, then that means it's not symmetrical in any way. There are only two types of symmetry we're concerning ourselves with. Even, which is symmetrical with respect to the y-axis, and odd, which is symmetrical with respect to the origin. If it's neither of those, we don't talk about symmetry. So now let's find out how to determine if functions have a symmetry or not, and if they do, what the symmetry is. Without using a graphing calculator, is this function odd, even, or neither? Well, since our test for the oddness and evenness is to determine f of negative x, then that's what we're going to do. If f of negative x gives us the exact same function we started off with, then it is even. If f of negative x gives us negative of the function we started off with, then it's odd. And I want to point out to you that negative f of x means negative 1 multiplied by f of x. So we have to determine f of negative x. Now, how do we do that? Well, if I said to you, what is f of 3 equal to, you would replace x in the original function with 3. If I said, what is f of r equal to, then you would replace every x in the original function with r. What I'm going to do is replace every x in the original function with negative x, because I'm finding f of negative x. So I'm going to get, when I replace every x with negative x, 2 multiplied by negative x raised to the 5 minus 3 multiplied by negative x, which is going to give us, well, when we take a negative raised to an odd exponent, it retains its negativeness. So 2 multiplied by negative x raised to the 5 would give us negative 2x to the 5. And then negative 3 times negative x is positive 3x. Now we have to ask ourselves something. Is this result, which is f of negative x, is it the same as the original function? Well, no, it's not the same as the original function. But we can see that it's the negative of the original function. You can either see that by just saying that all of the terms are negatives of each other, or if you wanted to, you could factor out negative 1 and be left with 2x to the 5 minus 3x. But this is f of x. If you look at the top where we started, that's f of x. So f of negative x equals negative 1 multiplied by f of x. Well, that means it's odd. So this function is odd. All right, let's take a look at b. Ultimately, for all of these, you need to determine f of negative x, which means that in the original function, every input becomes negative x. On the top, you have negative x quantity cubed, which gives us negative x cubed. And there's a difference between what I have written on the top, which is in brackets negative x raised to the 3, and what I have written on the bottom, which is negative 1 times x to the 3. They're equal to each other, but they mean slightly different things. The top means you're going to cube negative of x. The bottom means you're going to multiply negative 1 by x cubed. On the bottom, negative x raised to the 5 gives you negative x to the 5 because 5 is an odd exponent. So you're going to get negative 2x to the 5. And then we end up with plus 3x. And we have to ask ourselves how that compares to the original function. Is it exactly equal to the original function? And it turns out it is. Because if I factor a negative 1 out of the bottom, I'll be left with 2x to the 5 minus 3x. And I can then cancel the factor of negative 1 on the bottom with the factor of negative 1 on the top. And what I am left with is x cubed over 2x to the 5 minus 3x, which is f of x. So since f of negative x is the exact same thing as f of positive x, that means that this function has an even symmetry. And the last example, well, let's go ahead and put negative x in. We'll have f of negative x is equal to negative x quantity squared over 2 times negative x quantity cubed minus 3, which gives us positive x squared over negative 2x cubed minus 3. And the first question is that equal to f of x? Well, no, it's not. It's not the same. Is x squared over negative 2x cubed minus 3 equal to negative 1 multiplied by the original function? Well, no. Negative 1 multiplied by the original function would be negative x squared over 2x squared minus 3. And even if you decided to multiply that negative 1 by the bottom instead of the top, you're still not going to get what we got, which was x squared over negative 2x cubed minus 3. In other words, since f of negative x is not the same as f of positive x, and since f of negative x is not the same as negative 1 times f of positive x, there is no symmetry in this function. And that's it. Fairly short lesson, fairly to the point idea here. You need to be able to use algebra, not a calculator, to determine if functions are symmetrical or not. So on page 204 of your textbook, questions 1 and 2 are the practice problems. And I hope you have a great rest of the day, and we will talk to you soon. Take care.